So in question 2, we're asked to evaluate the following expression given that angle A is 20 and angle B is 74 degrees. So what you need to do is wherever you see B, you need to substitute 74 degrees. And whenever you see an A, we substitute 20 degrees. So I'm just going to rewrite this expression and I'm going to substitute these values. So what you can now do is you can just use your calculator and punch this whole thing as it is on the calculator. So it's 10, 3 into 74 degrees divided by sine of 74 minus 20 plus cos 20. So notice I used the bracket here on the calculator. I put this whole expression in brackets because you're dividing by the whole expression. So don't forget to include the brackets, these brackets, on the calculator. So this gives us 0.5148. Correct to do decimal places, there is 0.51. So moving on to the next question, we're presented with a cast diagram. So it says in the diagram below, theta is the angle in the first quadrant. So we're given theta to be in the first quadrant. S is a point 2 and 3. So we're given the coordinates of S. So we're asked to determine the size, or we need to determine sine theta, and we need to determine sec theta, cosec theta, right? So you'll notice at this point, the coordinates help us locate where point S is. So we see on the diagram that S is 2 units away from the origin on the positive x-axis. So this here is 2 units. So your x value is 2 units. And S is 3 units away from the origin on the positive y-axis. So our y is equals to 3. And we don't have r. So we're working with a right triangle. We need to find r. We need to use Pythagoras theorem. Before we find r, we might as well label our right triangle. With respect to theta, this is your adjacent. This is your opposite. And this here is your hypotenuse. So let's go ahead and find the hypotenuse. So we can say, according to Pythagoras theorem, the square of the hypotenuse is equals to the sum of the squares of the other two sides. So this is 2 squared plus 3 squared. This is equals to 4 plus 9. And 4 plus 9 is 13. Therefore, r squared is equals to 13. And this implies that r should be equals to the square root of 13. So r is equals to the square root of 13. So by definition, you know the sine of the angle, sine of theta, should be equals to the opposite over the hypotenuse, or y over r. This comes from the acronym SOHCAHTOA. So now we can just substitute. Our opposite end is 3, and our hypotenuse is square root of 13. So we can quickly rationalize the denominator. We can multiply this by 1, but 1 is as good as square root of 13 over square root of 13. So this is equals to 3 square root of 13 all over 13. In the second part of the question, we have two reciprocal trigonometric ratios sec theta and cosec theta. So let's go about finding the individual reciprocal trig ratios. So you know sec theta is 1 over cos theta. I usually remember it by the last letter. The c's correspond here. So to find sec theta, let's find cos theta. So cos theta is adjacent over the hypotenuse. The adjacent is 2 and the hypotenuse is square root of 13. So therefore, because sec theta is the reciprocal, it means sec theta then becomes root 13 over 2. I think let's just put this one side. Let's put it here. Okay. So now we have to go about finding cosec theta. So cosec theta by definition is 1 over sine theta. I remember this were the s's here, right? So to find cosec theta, we need to find sine theta. But we have sine theta to be 3 over root 13. So therefore, cosec theta should then be root 13 over 3. So now we can evaluate this whole expression by multiplying the two terms. That is multiplying cosec theta by sec theta. So we can say sec theta multiplied by cosec theta should be equals to sec theta is root 13 over 2 and cosec theta is root 13 over 3. So this is equals to 13 over 6. Right, so moving on to the next question, it says without using a calculator, determine the value of this given expression. So when analyzing the expression, we see we have angles 30, 60 and 60. So we have to construct a 30, 60, 90 triangle. So the next thing to do would be to evaluate each of these trig ratios in terms of this triangle. You have to remember or memorize this triangle. So then cos theta, cos 30 degrees would be adjacent over the hypotenuse, which is root 3 over 2. So cot theta is the reciprocal of tan theta. So we need to find tan theta in order to find cot theta. So tan of 60 degrees is equals to adjacent side over the hypotenuse, or opposite over adjacent. So that will be opposite, which is root 3 over the adjacent, which is 1. So therefore cot 60 degrees would be the reciprocal. To find the reciprocal, we have to flip these two. So the denominator becomes the numerator and the numerator becomes the denominator. So this is 1 over root 3. And finally, we need to find cos 60 degrees. So cos 60 degrees is equals to the adjacent, which is 1 over the hypotenuse, 2. So now we can put these all together to evaluate that expression. So this would be equals to cos 30, we saw is root 3 over 2, root 3 over 2 multiplied by cot 60 is 1 over root 3 plus cos 60 is 1 over 2. So root 3 and root 3 cancel here. So we're left with half plus half, and half plus half is 1. And in 2.4, they ask us to solve for x for the trigonometric equation. So we can write this as 3, but then they give us a restriction. They say x has to be between 0 and 90 degrees, with 0 and 90 degrees included. So we must bear that in mind. X over 3 minus 6 is equals to 0. So then 3 times 10 x over 3 should be equals to 6. So we can divide throughout by 3. We do so because we want to eliminate this 3 here. So divide by 3, divide by 3, 3 and 3 cancel, 3 goes into 6 twice. So this is 10 of x over 3 is equals to 2. So this becomes, therefore, x over 3 should be equals to 10 inverse of 2. And if we plug 10 inverse into our calculator, 10 inverse, right, so this is 10 inverse of 2, it's 63,43. So x over 3 is equals to 63,43 degrees. So therefore x should be equals to 3 times 63,43 degrees, and this should be equals to, so this here you multiply it by 3, and that should give us 190,30, correct to 2 decimal places, degrees. But remember, x needs to be between 0 and 90 degrees. So because of that, we say therefore x has no solution. For the above, x cannot be equals to the given angle, because x needs to lie, x as a domain, it needs to lie between 0 and 90 degrees.